In this video, we explore the three common types of storage: optical, magnetic, and solid state. The device that reads and writes data from secondary storage is generally referred to as the drive. What the data is actually stored on is referred to as the media. Let's start by looking at optical storage devices. So in the case of optical storage, we have an optical drive and a choice of media, which includes compact disc read-only or CDR, compact disc read-write or CDRW, digital versatile disc read-only or DVD-R, digital versatile disc read-write or DVD-RW, and Blu-ray, which was designed to supersede DVD and has the greatest storage capacity of all the ones mentioned. As a general rule, CDRs became popular for storing and distributing music, and CD read-write RWs as a backup option. DVD-R became popular for storing motion pictures and movies, and DVD-RW as a more useful backup option as it had greater storage than compact discs. With development of high-definition motion pictures, greater storage was required, and Blu-ray became popular as an alternative to the digital versatile disc. The field of music and film storage has seen many drives and media come and go over the years, but these are devices that have become most popular. All optical drives work by shining a laser at the media and processing the reflection from the media. In the case of read-only drives, so CDRs and DVD-Rs, the surface of the disc is physically burnt by the laser, creating what are known as pits and lands, suitable for storing zeros and ones. More accurately, it's the point where the pit starts or ends which causes the laser light to scatter, and thus is not reflected as well. It's this change of reflective and non-reflective areas which is read and interpreted as the zeros and ones. Clearly, once the surface has been burnt, it cannot be changed, making the media read-only. It's possible to press optical discs many thousands of times, and it makes distribution very easy. For example, in the past, when a popular artist released a new album or a new film became available for home viewing, the demand was likely to be high. In the case of writable drives, CDRWs and DVD-RWs, the chemical composition of the disc is changed by a reversible chemical reaction. This means the data can be written many times. There are many positives as optical as a storage media, including being cheap to produce, lightweight, and highly portable. DVDs store more data than CDs because the pits and lands are smaller and closer together as the laser technology has increased the precision. Data is read and written from the inside of the disc to the outside in a spiral. This can make them slow devices for accessing data. An optical media is also prone to scratches. Let's now have a look at magnetic media. Most hard disks in typical computer systems use magnetic disks. Imagine a typical magnet. It has a north or south polarity. This is ideal for storing zeros and ones. Over the years, the technology has been refined significantly to pack an ever-increasing number of magnetized compounds in the same space. As a result, magnetic hard disks today have an extremely high capacity. Hard disks have a drive head that has to physically move over the surface of the disk. This is the clicking sound you can hear from your computer. The drive head makes the drive a little slower than drives with no moving parts, and because this is a mechanical component, it will eventually fail. Tapes have also been popular magnetic devices in the past. They used to be considered extremely large in capacity and therefore were ideal for backups. Due to their small size and portability, keeping an off-site backup was easy with magnetic tapes. Unfortunately, because they can only be read and written sequentially from start to finish, this impacted significantly on how data could be stored on these devices. They were extremely slow in comparison to alternatives. They have been largely superseded by portable hard disks and cloud storage. Solid-state drives are gaining in popularity, being small, lightweight, and very quick to access data. They also operate without noise. There are many different types of solid-state storage, and they're beginning to replace hard disks as their capacity increases and their cost decreases. Solid-state drives work by a flow of electricity forcing electrons into floating gates between two oxide layers. This causes a change in the charge in the floating gate, and this can be measured as a 0 or a 1. Over time, the oxide layers deteriorate, meaning that eventually the transfer of electrons will become unreliable. This means that solid-state media has a limited number of read-write cycles and therefore a limited lifespan. So just to recap, the common types of storage include optical, low capacity compared to other storage, slow to access data, but thin, lightweight and highly portable. Magnetic devices, a very high storage capacity, quick to access data, but it has moving parts which eventually fail, and the hard disk performs better if they're defragmented. And solid state, medium storage capacity, very quick to access data, no moving parts, very reliable, no noise, low power, no need to defragment, but has a limited number of read-write cycles and is still expensive compared to other types of storage.